Okay, so today we'll talk about chemistry of life. You remember there are different levels of organization of human body. You must remember chemical, cellular, tissue, organ, system, then the whole body, right? Organism. So smallest level is the chemical level, which is the chemistry of life. So chemical level includes the atoms and molecules. So first we will talk about the atoms and from where the atoms come. To know the atoms, you need to know elements, isotopes, radioisotopes, and subatomic particles. Okay? So we'll talk about those things. We'll talk about the bonds. Bonds are the attractions that hold the atoms together. Okay? So we'll talk about different types of chemical bonds that hold the atoms together. Then we'll talk about chemical reactions. You all know that inside your body many chemical reactions are being taken place. So we'll talk about the chemical reactions. Then we'll talk about the organic and inorganic compounds. Human body consists of both organic and inorganic compounds. Okay, so our body consists of organic and inorganic compounds. So we'll talk about those. Then we'll talk about the most abundant inorganic compound in the body, which is the water. Human body is mostly water. So we'll talk about the properties of water. Then we'll talk about briefly acids and bases. Then we'll talk about so these are inorganic compounds. By the way, water is the most abundant, right? And acids and bases are also inorganic compounds. So we'll talk about those. Then we'll talk about the organic compounds, proteins, carbohydrates, fats. These belong to organic. Okay? And then we'll talk about the source of energy. So first, to know the atoms, you need to know what is a matter. Matter is anything that occupies space and has mass. Anything you see that occupies space and has mass is a matter. Now, matter exists in three forms: solid, liquid, and gases. So, in three forms. Okay? You know that solid things occupy space, right? You know liquid occupies space. You also know that gas occupies space. How you know gas occupies space? You don't see gas, right? You see solid and liquid things. But you know when you put air inside the tire of your car, right? When it gets, it expands. You put air in balloon, that gets big, right? So you know that air also occupies space, right? So it is also a matter. So three forms on Earth. Now, matter consists of elements. So matter consists of elements. Okay? And if you see the structure of an element, inside the element you will find atoms. Atoms. Okay? And inside the atoms you will find subatomic particles. Okay, subatomic particles. So, from small to large, this way. Okay, atoms are the building blocks of elements, and elements are the building blocks for matter. Make sense? Okay. So, until today, only 92 elements have been identified. Okay? But matters are so many. Only if you see inside this room, you will find more than 92 different matters, right? Different solid things or liquid things. But the elements are only 92. That means by combining two or more elements, we get matter. Make sense? So we can combine 2, 3, 4, or 5, or even if we combine 2, I can take 60% of this element, 40% this, right? Or 50% of this, 50% of that. Does it make sense? So you see, only by 2 you can get different matters, right? Different matters. So that's why matters are so many, because we use different ratio and different numbers of elements to form matters. Elements are indicated by symbols. If we use only one character, we always use capital or uppercase, okay, letter. For example, nitrogen or carbon. Okay, so these are elements. If we use two letters, for example, sodium, the first one is capital, second one is lowercase. So uppercase, lowercase. Calcium, Ca, right? This is upper, this is lower. So all these are elements. Make sense? So if we use one, always uppercase. Two, the second one is lowercase. Now, why we need to know the elements? Because, as I have mentioned, our body consists of elements. 4 elements form about 96% of body mass. So those 4 are present in huge amount, right? Which 4? Carbon, hydrogen, oxygen, and nitrogen. Okay, so those 4 elements form about 96% of your body mass. There are other chemicals present in the body in a small amount, and those are also very important. For example, calcium, phosphorus, potassium, sulfur, sodium, chlorine, magnesium, iodine, and iron. These are other chemicals or elements, and these are also very important, although they are present in a small amount. For example, let me give you a couple of examples. You know that if someone has iodine deficiency in the body, that causes problem in thyroid gland, goiter. Have you heard goiter? So iodine deficiency can lead to diseases. Iron deficiency, you know, iron is very important. All of you know, right? Iron deficiency causes anemia. Have you heard that? So you see, calcium deficiency will cause fatigue, muscle paralysis. Okay, so you see, those are present in a smaller or trace amount, but they are also extremely important for your life. So that's why you need to know the elements. Okay. Now, elements are formed by atoms, as I have mentioned here. Right? Atoms are the building blocks of elements. So, we'll see the structure of an atom. If you see an atom, it has two parts. Nucleus in the center and shell is the outer boundary. Okay? So this is the nucleus, atomic nucleus, and this is called shell. Okay? In the nucleus, you have two subatomic particles. One is called protons and another is called neutrons. So protons and neutrons are subatomic particles present in the nucleus. Okay, so neutrons, protons. And on the shell, you have another subatomic particles that are called electrons. Okay, so electrons are present on the shell. Okay, so those are three main subatomic particles: protons, neutrons, and what? Electrons. Protons and neutrons are in the nucleus, and electrons are on the atomic shell. Now, electrons carry negative charge, minus. Protons carry positive. So protons are positive and electrons are negative. And neutrons are neutral, NN. PP, positive proton, okay, easy to remember, P, positive, okay, and neutral. Electrons are negative. Okay, now you see here the number of protons in the nucleus and electrons on the shell are equal. So how many protons here? 1, 2, 3, right? So how many electrons should be on the shell? 3. So 3 plus and 3 minus. Make sense? So equal number of protons and electrons make the atom what?
Neutral.
Neutral. Make sense? So atoms are neutral. Okay, neutral. Because of same number of protons and electrons. The atoms usually have more than one shells. So this is one shell, there could be more. This is another shell, there could be more, another shell. So the electrons could be present in all those shells, but as you go outwards, the number of electrons increase on the shell. Okay, so anyway, so an atom could have more than one shell. Most of the atoms have more than one shell, okay? And outermost shell contains most of the electrons. And outer shell is called the valence shell. Outermost shell is the valence shell. We'll talk about that just now, that valence shell. Now, electrons continuously orbit the nucleus. That means what? The protons and neutrons are sitting in the nucleus, but electrons are moving, circling around the nucleus continuously, okay? So, the electron orbits the nucleus, moves. One proton is considered as, the weight of one proton is 1 dalton or atomic mass unit. So very simple, one proton equal to 1 dalton or atomic mass unit. That's the unit of weight. One neutron is also said equal to 1 Dalton or atomic mass unit, AMU. So protons and neutrons have weight that we can measure, but electrons are considered as weightless. So small the weight that we cannot measure. So we consider that as weightless. Okay, so that's the weight of particles. Here you see helium atom. In the nucleus you have 2 protons, 2 neutrons, and on the shell you have 2 electrons. So it is neutron. Electron cloud. When you see an electron under very powerful microscope, what we see, it looks like a ball of cloud. Why is that? Because you see the nucleus is in the center, and what happens, the electrons are moving, right, like this, in different planes. So if it has 20 electrons, like 20 electrons are encircling, make sense, in different planes. So it looks like a sphere, a ball. Okay, that is called the cloud. You know, if I tie this and move very fast, it will look like a circle, right? Something if you move very fast. So the electrons are moving in different planes, directions. So helium, and this is another lithium. You see same number of electrons and protons. Hydrogen is an exception. Why? Because hydrogen doesn't have any neutron. No neutron in the nucleus. Only 1 proton and 1 electron. So that is an exception. Hydrogen atom. Atomic number and mass number. Atomic number is very simple. How many protons you have in the nucleus? That gives the atomic number. So what is the atomic number of this? 3, because 3 protons, right? So how many protons in that atom? That is the atomic number. Very simple. Now, mass number is the number you get by adding protons and neutrons. So what is the mass number, atomic mass number? 6. Make sense? 3 plus 3. So how many protons and neutrons together in the nucleus? That is the mass number. Is it clear? So number of protons is the atomic number, and number of protons and neutrons together give the mass number. Okay. Okay, so you know that in the nucleus, in an atom, the number of protons and on the shell, number of electrons are same, right? So that makes it neutral, same number of positive and negative. And also, the number of protons and number of neutrons are usually same, and they maintain a balance, same number of protons and neutrons in the nucleus. So everything is same. That is usual. Now what happens, what can happen, sometime the number of neutron can be less than the number of proton. So number of neutron can be changed. So if this atom loses a neutron, now you see how many protons? 3, right? And how many neutrons? 2. So the number of protons and neutrons are not same, and in this case this atom will be termed as an isotope. Okay, isotope. So, if the number of neutron changes in the nucleus, number of neutron changes in the nucleus, that makes the atom an isotope. Okay. So now you see the mass number of an atom, like let's go back to atom 3 and 3. So mass number was what? 6. Right? In this atom, mass number is 6. Now if the number of neutron changes, the mass number also changes, right? So the mass number of an atom and isotope is different, okay? Okay, now most of the isotopes are quiet, although the number of protons and neutrons are not equal. The balance is not there, but they will remain quiet most of the cases. Okay, will not create any problem, but sometime due to that imbalance, what can happen, the nucleus can radiate. Due to that imbalance, the nucleus can radiate or emit radiation, and in that case this isotope will be termed as radioisotope. Radioisotope. When the atom or isotope emits radiation from the nucleus, that is called radioisotope. Okay. If it is quiet, no radiation, isotope. Okay. If it emits radiation, radioisotope. Radioisotopes, probably you have heard, could kill the living cells. Could be very harmful, right? Can kill the living cells. So not good, right? Radioisotopes are not good. But now we know how to use the radioisotopes for our good uses, good purposes. Example, since we know that radioisotopes kill the living cells, right? We can use it to kill the cancer cells or tumor cells, right? To destroy the tumor cells. So we do that. Radioisotopes are also used to in X-ray, taking pictures from inside structures of the body, because they can pass through the tissue. Okay, so also radioisotopes are used to keep the fruits, preserve the fruits and some food stuffs. Okay, so those are the good uses of radioisotopes. Okay, in clinical purposes as well as to preserve the food. Chemical reactions. Chemical reactions are the reactions between the chemicals. Okay, so many different types of chemical reactions take place inside the body, as you already know. Now, one type of chemical reaction is called ionic reaction. Ionic reaction. Okay. What is that? Let's go back to the structure of an atom. So this is an atom. It has 2 protons, 2 neutrons, and 2 electrons. Okay. So here protons are what? Positive or negative? Positive. Remember PP. So how many positive here? 2, right? in the nucleus. Make sense? And electrons are negative. So this is one, this is another. Okay? So 2 positive, 2 negative in this atom. Okay? Now let's see another atom. This one has 3 protons, 3 neutrons, that means 3 positive, and of course 3 electrons, because we know atoms are neutral, right? So this one is neutral, this one is neutral too. Same number of electrons on the shell and proton in the nucleus. Make sense? So both are neutral. Is it clear? Okay. Now, when these 2 atoms come close to each other, if on the shell of this one there is an empty space, open space, okay? When these 2 will come close to each other, what will happen? This electron can jump from here to this open space. Make sense? So now you see this one got an electron and this one has lost an electron. Make sense? Yes?
Why would that happen if they were both neutrals?
Why that happens? When the atoms, they come close to each other, for chemical reactions they must come close to each other, okay? And only that exchange will occur if the empty or open spot is there, okay? And if they don't come close enough to each other, that will not happen, okay? So molecules or atoms are brought together by ATP. We have ATP in the body, right? Energy that needs to bring them together to make the chemical reaction happen. Okay, so that's the natural process. Okay, so since there is an empty spot here, this electron will jump from this shell to this shell. So now this one got one more electron. So this will become what?
Negative.
Negative. Makes sense? Because how many protons? 3. How many electrons? 4. So 1 electron more, right? In this one. So this will become negative. No more neutral. This one has lost electron, right? So now this one has 2 protons but only 1 electron. Makes sense? So this one will become what?
Positive.
Positive. And now that attraction will be created between positive and negative, and this is the bond. This is called ionic bond. Ionic bond. And this reaction is ionic reaction. So ionic reaction occurs by forming ionic bond, and ionic bond is formed by donation or accepting electrons between the atoms. Okay, so now you see, when the atoms become positive or negatively charged, these atoms are now called ions. So now this is positive ion, this is negative ion. Okay, when they are neutral, we say atom. When they gain positive or negative charge, that means electrical charge, they are now called ions. Okay, so by forming ions, attractions or bonds are created. Okay, and that is called the ionic bonds. So that is one type of chemical reaction. Okay, now positive ions are called cations, and negative ions are called anions. Okay, so they have different names: positive cation, negative anion. Okay, So that is one type of chemical reaction. Another type of bond is called covalent bond. Covalent bond is not by donating or receiving electrons, but by sharing electrons. By what? Sharing. So what happens, this is one atom, these are the electrons, protons, okay, neutrons, and this is another atom, okay. So what happens, you see, these two atoms are sharing some of their electrons and forming bonds. So these two pairs are being shared between these two atoms, and that is sharing. So basically the electrons are not leaving the atoms, staying there, right? But they are getting attached to each other. That's why we say sharing the electrons between two atoms. And that is called covalent bond, very strong bond. Covalent bond is a strong bond. Okay. Another type of bond. Now, let's go back to indicate the covalent bond. We use lines. For example, if this is carbon, this is another carbon. What we will do? We will use this formula. How many pairs are being shared? 2 pairs, right? So 2 lines. If 3 pairs are shared between 2 atoms, we will do what? We will use 3 lines. So that indicates the covalent bond and how many pairs of electrons are being shared. Hydrogen bonds are weak bonds and found between water molecules. You know that your body is mainly water, so we have plenty of water in the body, and the water molecules must stay together. It is important, right? Because the body fluid is flowing, right? And the molecules, water molecules, must stay what? Together, right? To function. So water molecules are attached to each other or held together by hydrogen bonds. You know, water has 2 hydrogen and 1 oxygen. So H2O, we know that. 2 hydrogen, 1 oxygen. So this is one water molecule. This is another water molecule. Another water molecule. Okay. So three water molecules, okay? And oxygen is weakly negative. Hydrogen is weakly positive. So what happens? The weakly negative attract the weakly positive. So these are the bonds between positive and negative. So these are hydrogen bonds. Hydrogen bonds. And these are weak bonds and found between water molecules in the body. Okay. this is two atoms are talking to each other, okay? So one said, the first one, damn, I lost an electron. Second one is asking, are you sure? First one said, I am positive. That means what? By losing electron, it becomes what?
Positive.
Positive, right? So atoms become positive by losing electrons. We know that. So quickly, I have explained three different types of bonds. So you can see here, sodium and chlorine. And from the outer shell, one electron moved here because there was an empty spot there. So now you see the sodium becomes positive, chlorine becomes negative. Make sense? So now positive and negative, this is cation, this is anion, and they will attract each other and will form sodium chloride. Yes.
So, I'm sorry, why do the reactions happen? Is it just because they near each other, or is it,
Why reactions happen in the body?
yeah, why do
This is a biological reactions. All reactions are biological processes, and that must happen inside the body to maintain homeostasis. If chemical reactions doesn't happen, then homeostasis will not occur. So to perform the function, chemical reactions must happen. For example, when you eat food, right? You eat glucose, and right, glucose enters into your body. Then the glucose molecules must get attached to each other by the bonds to form glycogen to be stored in the body. Just an example. There are thousands of examples, right? So this is just one example that glucose molecules must bind to each other. Make sense? To be stored in the body. Now, when you are starving, what happens? Why you need to store glucose? Because your body may need it in future. Might need it. So when you are starving, that glycogen will release the glucose. Make sense? To give you energy. And that is also chemical reaction, glycolysis, breakdown of glucose to release what? Energy. So I just gave you one example, right? Related to glucose. There are thousands. And all those chemical reactions must happen. You understand that? So formation of glycogen from glucose, chemical reaction. Breakdown of glycogen to release glucose, chemical reaction. And breakdown of glucose to give ATP is also chemical reaction, right? So you need all those reactions, and that's the biological process, okay? That's how the body is built, and we need for our survival, okay? Okay, so you see how sodium chloride is formed by ionic bonds. Two nitrogen are attached to each other, by three pairs of electrons. So that's why you see three lines between nitrogen, and these are covalent bonds. Hydrogen bonds between the water molecules that I have mentioned, weak hydrogen, weak oxygen, weakly positive, weakly negative. They attract each other, and that is hydrogen bond. Because of hydrogen bond, you see the surface tension in water. Water molecules try to stay together. You know, sometimes you will see that small flies can easily walk on water surface, right? Because there is a surface tension. Molecules are attached to each other. Make sense? If you put your finger in water and take out, you'll see a nice ball is formed, right? Why? Because the water molecules are trying to stay together. That's why that ball is being formed, right? So, those are the examples that water molecules are together. Okay, so those are three types of common types of bonds. Now, chemical reactions. Chemical reactions are many different types, but we can group them into three types of chemical reactions: synthesis reactions, decomposition reactions, exchange reactions. Now, I already gave you an example. You must remember, just to answer your question, that when you eat carbohydrate, right, glucose is taken into the blood. So these are glucose molecules, okay? Glucose molecules are the smallest carbohydrate molecules, so glucose, okay? And after glucose enters into your body, if you take excess amount of glucose that your body doesn't need immediately, that excess amount of glucose will be stored, that I have mentioned, right, as what? Glycogen. Make sense? So, small glucose molecules join together to form a large glycogen molecule. Make sense? So, many small glucose molecules join together to form a large glycogen molecule, right? So, this is called synthesis. From small to large compound molecule. And usually synthesis reactions help to what? Store in the body. Okay?
You said that's from small to big.
Here you see 6 small molecules, right? This is one glycogen molecule.
Okay.
So bigger, right? And complex. From small and simple to bigger and what? Complex. Okay? So that is synthesis. Now I mentioned that if you are starving, then what will happen? Your body, you are not getting food from outside, right? So your body needs glucose to produce ATP. So in that case, what will happen? The glycogen breakdown will occur to release glucose. Make sense? To release glucose. So that is opposite of synthesis, and that is called decomposition. Breakdown. Decomposition. We know decomposition means breakdown, right? You know that word. After death, what happens? Body decomposed, right? So you know that. Breakdown. So this one happens when your body is starving and needs to use the stored glycogen. Another example, you know amino acids. These are amino acids, small molecules, protein molecules, and when amino acids get joined to each other, attached to each other, form a chain. This is a protein molecule. These are amino acids. So you see, small amino acids join together to form a protein molecule, which is amino acid chain. So protein molecule is actually an amino acid chain. Is it clear? So one single molecule, this one, protein. And here you have 5 or 6 amino acid molecules. Make sense? Now, if I break these bonds, these are called peptide bonds. Peptide bonds hold the amino acids together in protein. Now, if I break these bonds, then what will happen? We'll go back to this form, right? Breakdown of protein chain will release the amino acids. So that is decomposition. So this is again synthesis. This is decomposition. Okay? So from large to small, decomposition. Exchange reactions. Another type of reactions are called exchange reactions. What happens two chemicals, for example, sodium hydroxide and hydrochloric acid. Have you heard these names? Some of you, right? If you have chemistry, did you take chemistry in high school? Okay, so you should know. These are very common chemicals, right? Sodium hydroxide is a base, and hydrochloric acid is what? Acid. I said hydrochloric acid, right? So it is an acid. So sodium hydroxide is the most common base, and hydrochloric acid is a common acid, right? So you see here, okay, now when these two chemicals, chemical reaction occurs between these two chemicals, what happens? They exchange their parts. Okay, so now you see this and this, they join together to form what?